All right, so y'all keep working if you want to. There's a couple questions on the board on the miscellaneous exponential log practice from yesterday. We've got number 7 up there, which is easily the trickiest problem on this whole review or anything we've done, I think. It was a math team question from a few years ago, and it's exceptionally ugly because the answer could be written a zillion different ways, but I'll walk through that first. Okay, so I'm gonna put it here, but I'll scroll up. So 3 equals 2 Okay, so on a problem like this you're trying to solve, and when you solve, we know we want to get x kind of on the line, not in the denominator. We can't have them on both sides. And really, I don't have a rule for eliminating the 3 and the 2. I just don't. But I do have a rule for eliminating one base. So I'm just going to try. You can pick one. Most people just kind of pick the 3 because it's already on the left. But you could pick either one. To eliminate that 3, I would log both sides with a base of 3. Now, this means my answers are going to have log base 3 parts in them. If I were to do the same thing with log base 2, my answers would have log base 2 parts. So if this was ever a multiple choice question at a tournament or something, I would look at my answers, and if my answers were all in base 3, I would use log base 3. But it's your choice. And at the end, you can manipulate the answers so they all look the same, but your answer is going to look really ugly, and it could be a million different things, but that all equal the same thing. So right here, this cancels, but this does not. So you end up with 4x minus 2 equals log base 3 of 2 raised to the x minus 1 power. Okay? So, give me a second. All right, so what do we do now? I've got an x here, and I've got an x floating up there. Well, how am I going to get that x down kind of in the numerator as opposed to being in a power? Well, I can swing it to the front, which is not a lot of what we've done, but now I couldn't do it up here because it wasn't a logarithm. But now that it's a logarithm, I can swing the whole x minus 1 out here to the front. Now, this is where most people freeze up. Okay, so if you saw me do this, I don't know if I did this in the video or not, I don't remember if we got to it, but at this point, I want you to think like this. If I had given you this, and you had x minus 1 over here, so same problem, but instead of having log 3 of 2, you had something like 7. If you had had that, what would you do to solve that on the right? You'd probably distribute the 7, because the 7 is a number, right? It's just 7. Well, what is log base 3 of 2? It's a number too. I don't know what it is. It's just log base 3 of 2. It probably has a decimal value of 0.8 or something like that if you typed it in your calculator. But the bottom line is, I can distribute that in, and that would give me 4x minus 2 equals 7x minus 7. Well, I can distribute that in. Well, if I divided by 7, is that going to help me here? But then I also have an x on the left. I'm not saying you couldn't do that, but you still have an equivalent mess. You have an x divided by 7 as opposed to an x multiplied by 7. The bottom line is I have to get all my x's on one side in the numerator. So if I were to divide by log base 3 of 2, I still have x's on opposite sides, which I'm gonna have to do something about. But if I distribute it, check it out. I end up with x log base 3 of 2 minus 1 log base 3 of 2. Now, think about this like it's that. What would you do here next? And this is how I bail myself out when I'm stuck. If I'm stuck, I just think, well, let me just pretend that's a number, and what would I do? Oh, I distribute it. Okay, let me try that. And then if I distribute it, what would I do next here? I mean, wouldn't you move all your x's to one side and all your constants to the other? Well, let's do it. I'm going to leave that 4x there, and I'm going to move this to this side and move that to that side. Because remember, log 3 of 2 is just some number. It's just ugly. And I don't have a calculator to simplify it into a decimal. Now, once I did that, I would get this. Now, over here, you would probably not have written this. You would have written negative 3x equals negative 5, right? But just for the sake of making it have a parallel, what would you do to get my x's together here? And if you tell me, oh, I'd go 4 minus 7 is negative 3x, that's true, but that's what we taught you when you were like in 6th grade, because we hadn't taught you factoring yet. And think about it, 6th grade is you're 12, right? Your brain is not even close to being fully formed, right? I mean, you're going to keep forming your brain, especially the frontal lobe, all the way through age 25, 27. Okay, so right here, we taught you, hey, like terms, add the coefficients. And we talked about like terms, but you know what you were really doing? Factoring. You were factoring an x out. And when you factored the x out, then you were able to simplify. That's what you were doing. So with that in mind, what could you do here? Factor the x out. And then here, what would be the last thing you did once you factor the x out? You would divide by the rest of that junk just to get rid of it. Well, divide by it to get rid of it. And I would certainly take this as an answer. X equals that ugly thing. But let me just show you how dirty Vestavia was. I don't know if anybody got this right. Here's what they did. They took this 2 minus log base 3 of 2, and that was not an option. There was something really close to that, which made everybody go, oh, I probably made a careless error. I'll take that, A. But here's what they did. They changed the 2. This is really dirty, as dirty as they've ever been, probably. Because anybody who got to this deserved to be right, I think. But right here, they changed the 2. Remember, this is a log base 3 to log base 3 of 9. They changed the 4 to log base 3 of 81. Then they subtracted the 2 logs by doing what? By changing it to 1 log and division on the top and the bottom. And then if it's not dirty enough, they use the change of base rule to undo this. You see that? Because log of this over log of this could be any base you want. And that to me is pretty dirty. I don't know if anybody got it. It's probably like number 24, number 25 on their test. But I'd take this. The thing that made it really brutal was all this stuff. So you don't need to do all that. This is fine. I don't know where you'd ever see something like this, but in real life, people that deal with logarithms are usually dealing with exponential growth and decay, or population growth, or carbon-14 dating, or financial situations, and you got a calculator out, you're approximating stuff. So the manipulation is way overrated here when you can just type that in your calculator and get a decimal. Yeah?
The calculus prep worksheet is stuff in that going to be on the test?
Sure.
Okay, can you do like one it's like e to the x?
Can you give me a number?
4, 5a.
5a? Okay. So that was 22b? No, that was 7. Okay, so for 22b, on this sheet, yeah, we'll get to it. On 22b, this was just a tricky little math team question. And it was actually a ciphering question. And I just threw it out there so you'd see it, but 26 letters in the alphabet, right? X minus A, X minus B, X minus C. Eventually, what are you going to get to?
X minus X.
X minus X? And what's X minus X?
0.
So eventually, somewhere right before this Z, right, X, Y, Z, you're going to have an X minus X that you're logging. You're going to be logging a 0. What's log of 0? D and E. So if that's D and E, then none of this matters, does it? Because at some point in here, that's going to give you log of 0, which is not exist. So if that doesn't exist, this expression is not going to have a value. But anyway, just throwing something at you. See what you can do. That's 22b. If you go to the review that we're talking about right now, looking at nothing, you go to the Calc Prep worksheet. This is way at the beginning. Y'all have a page number on this thing?
73.
Okay, and the reason why I gave you this Calc Prep worksheet was to help you see that all the logs that we deal with, all the little bitty rules of manipulating and stuff like that, in calculus it's more along the lines of, can you get rid of a natural log by exponentiating? Can you get rid of an exponential function by logging? Very basic. If you know those basic rules, you're going to be in good shape. So you want to know 5a. So 5a over here says, all right, says, if e to the x is y and e squared is w, then write the following expressions in terms of y and w. Okay, so I want to rewrite this so that it's written as e to the x's and e squareds. So on 5a, I look at this, e to the 4x plus 2. How could I rewrite e to the 4x plus 2 as something x and something squared? Anybody have an idea? Yeah, e to the 4x times e squared would be going backwards, but isn't like bases add exponents? Wouldn't that have made sense? Now, e to the 4x is not y, e to the x is. Can I rewrite this as an e to the x to some power? E to the x to the 4th? So if the e to the x is a y, you plug a y in there and get y to the 4th. And if e squared is a w, I can plug a w in there. And even if that squared wasn't squared, what if that was plus 20? How could I rewrite e to the 20 as an e squared term? So even if it was like something like a 20, you could rewrite that as e squared to the 10th, and you'd have w to the 10th. And you're rewriting it. And the goal of that is just to help you see that you can make some substitutions sometimes that will help you. Right? So that's 5a. Number 14 on this Calc Prep sheet.
Like, how do you know which way to graph? Like, I get like the above the x-axis and below the x-axis, but I don't really get like the.
Okay, so I gotta be honest with you. I don't really feel like at this point in your life, your math life, that you need to worry a whole ton about reflections and stretches and all that. The best thing I think that you can know about exponential functions is how to graph 2 points. So graph, and this is true for logs, graph 2 points. And what does every exponential function have? Horizontal asymptote. And if it's a log function, what does every log function have? A vertical asymptote. So these are exponential functions, right? 2e to the negative x. If you can just give me 2 points, and you know how to mark the horizontal asymptote, then you're going to be able to graph this. Because you know that the thing is going to follow the horizontal one way, right? Just like on a log, you know it's going to follow the vertical one way. So let's just get 2 points here. What are the easiest numbers to plug in there? 0 to me is a great number to plug into these, just like 1 is a great number to plug into logs. So if I plug a 0 in there, e to the negative 0 is still e to the 0, which is 1, and 1 times 2 is 2. So if I plug a 0 in, I get a 2. Now there were no shifts on this. If there were shifts, I would have done that first. So I'm going to mark 0, 2. And since there was no shift up and down, that is my horizontal. Now if there was a shift like plus 5, shift it up and the plus 5 is my horizontal. Now what if I shift it left or right? Is that my vertical asymptote? No, because exponential functions don't have vertical asymptotes. It's just a shift. So it's not an asymptote. Don't confuse those. An asymptote, it's not a shift. A shift is a shift. An asymptote, it has to follow out a certain direction. So I have a horizontal. Now there's 1 point. Now what's another number it's easy to plug into 2e to the negative x. Anything. You can plug in a 1, and I know usually 1's a good idea, but do you really want to do e to the negative 1? You can plug in anything you want, but do you really want to do 2.17 to the negative 2.17 power? I do not.
Plug in a negative 1.
Why not a negative 1? Pick something that makes your life easy, right? There's already a negative in there. So if I were to plug a negative 1 in there, the negative 1 becomes a positive 1, and e to the 1 is e, and double e, and what do you get? What's 2 times 2.7? 5.4? So at negative 1, I'm going to go up 1, 2, 3, 4, 5.4. Does that make sense? But I'm trying, like Pascal's trying to do the easiest thing he can do without a calculator, right? So he picked a number that was great in that regard, and I got about 5.4. Now look, if these are the only 2 points, and I have to follow a horizontal, isn't it pretty obvious that if I run through these 2 points, and I'm already heading in that direction, I've got to follow it out that way? Now, if I do that, let me ask you this question. Did you once think about the reflection that was over the y-axis? No. You just plug some points in. Did you once think about what's the 2 doing? It's stretching it. No. You just picked 2 easy points, plugged it in there, got their values, marked them, marked the horizontal, and the shift just took care of itself. Everything took care of itself. Try this next one. Actually, yeah, so this one goes with that, not these. But technically your rules hold. To negate the x, I do what? Reflect it over the y. And I did. I took a normal exponential function and reflected it over the y-axis and then stretched it up too. So it would have to be this one right here. And if you look at all these, they have similar situations. But all I have to do is plot a couple points and see which one it ends up being. Anybody else on anything before I cut the video? Does anybody have something from home? And no. Last call. Nobody? Looking through the review sheet, nothing jumps out at you? Okay, I'm about to cut the video, but if you guys at home have any questions, remember that we have a meet tomorrow. You are welcome to check in, put your name on there, and go study. Next week, I think because of the way the schedule fell, I was able to put an extra video on Wednesday, so we're actually going to have a learning day on that Wednesday. But because of the way I have to engineer the tests around the meets, I just had to lose a day. So anyway, I'll see you tomorrow. If you find any last minute questions, please join the meet and have them, and we can look over. All right?